Hey scholars, today we will learn about the geological timescale. Sounds fun, huh? Let's go over what you will learn in this lesson. Firstly, we will go over the history of how the geological timescale was developed by scientists. Then we will go into greater depth about what the geological timescale is and how its years are calculated and how to read the geological timescale. Moving into the next slide, we can see a picture of a scientist from 1669. The historical origins of the geological timescale can be traced all the way back to the 1600s, when a Danish scientist greatly advanced the development of geology through his observations. Nicholas Steno, as you can see here, Nicholas Steno, as you can see in this image, described three basic geological principles. First, he stated the rocks are laid down in a horizontal manner. Secondly, he stated the younger rocks units were deposited on top of older rock units. Third, he stated that every exposed outcrops demands an explanation. Later in the 1700s, another scientist named James Hutton developed the principle of uniformitarianism. Uniformitarianism, repeat after me, uniformitarianism, which explained the idea that the processes that shape the world now also shape the past. This principle explained that major events in the past have impacted the geological world of present time. James Hutton is also often credited to be the father or the founder of modern geology. Moving into the next slide, we can see another image here. And also in the 1700s, this scientist named William Smith determined that two strata from different sites can be regarded as similar in age if they contain the same fossils. For instance, if a fossil remain is found in both Africa and South America, then it can be regarded as similar in age, and perhaps both continents were joined together in the geological past. So fossils found in different sites can be considered to have common origins. Moving into the next slide, we can see another scientist. This scientist in the 1800s, born from a wealthy Scottish family in Scotland named Charles Lyell, supported Hutton's uniformitarianism's principle by adding that the present geological conditions are the key to understanding the geological past. Charles' idea explained that the geological events happening now have occurred in the past at the same rate as if they are observed today. So now that we have learned about these four major scientists, try answering this question by memorizing their names. Take 2 minutes and try to memorize those names. Then answer the question above. What major scientists contributed to the origin of the geological timescale? Starting from now, go. time is up. I hope you was able to memorize those names. Now, what is the geological timescale? The geological timescale is a chronological calendar that studies the history of the Earth, as you can see here on this image. The geological timescale relates the history of Earth since its formation. It relates the history from the early stages of our planet and the solar system 4.6 billion years ago to the present time. In geology, billions of years are also calculated in millions of years. For instance, 3.8 billion years ago is the same as 3,800 million years ago. How amazing it is. How do we know those numbers? How do we know those numbers? How do we calculate the age of those numbers that you can see here on this image? How geologists know? Moving into the next slide, we should ask ourselves this question. How do we calculate the age of strata in geology? We know this number in years by using absolute dating and relative dating. Moving into the next slide here, how do we calculate years in geology? Relative dating determines the years of the geological timescale by using the non-numerical comparison of strata of rocks and fossils based on its features. For example, the age of rocks with specific fossils compared to the age of rock found beneath. Absolute dating determines the years of the geological time scale using numerical values. For example, the number of years since the rock formed. So now let's take a quick comparison to both relative dating and absolute dating. So what we know about relative dating and what we know about absolute dating. Let's quickly summarize relative versus absolute dating. Now, what we know about relative dating, it provides a non-numerical comparison of strata of rocks and fossils based on their features. So now, let's compare relative dating versus absolute dating. What we know about relative dating, it provides non-numerical comparison of strata based on its features. Relative dating tells us the age of rock A compared to rock B. It uses qualitative methods of dating, and one of the values is that it cannot provide actual numerical numbers. For example, trilobite fossils are older than the dinosaur fossils. Now, what about absolute dating? Absolute dating provides numerical age of strata and rocks. Absolute dating tells us the age of rocks A in X numbers of years. Absolute dating uses quantitative methods of dating. It uses numerical methods of dating. And one of the biggest values is that it can provide actual numerical dates. For example, a good example of absolute dating, the dinosaur fossil is 250 million years old. Moving into the next slide. How do we read the geological timescale? Now, how do we read the geological timescale? Take 2 minutes to observe and analyze this image here to the left. Take note of the things that you observe, starting from now. Go. time is up, and I hope you came up with some good observations. Now, how do we read the geological timescale? The geological timescale is divided into compartments, which are the eon, as you can see here, the era, the period, the epoch, and the years, as well as the events. However, most geological timescale will show only the eon, era, periods, epochs, and years. Now that we know that the geological timescale is divided into compartments, let's review each of them. Moving into the next slide. How do we read the geological timescale? The first column here is what we call the eon. The eon. Major history events are characterized by these 4 eons, as you can see here in this image, as I am pointing with the mouse. The oldest time periods are on the bottom here. As you can see in this image here, the oldest time periods are found in the bottom, and the youngest are on the top. From the Hadean eon, which is the youngest, followed by the Archean eon, the Proterozoic eon, and the Phanerozoic eon, which is present time. Moving into the next category of the time scale. Moving into the next category of the geological time scale, we have the era. The era is a subdivision of an eon, and is divided into 4 eras, starting from the Precambrian as the oldest all the way to the Paleozoic, Mesozoic, and Cenozoic era as the youngest era. Moving into the next category, we have periods, and periods are subdivisions of eras. Moving into the next, we have epochs. An epoch is a subdivision of periods. Now, how can we learn this? Remember that eon is the largest and broadest category and compartment of the geological time scale. Era is a subdivision of eon, and periods is a subdivision of era, and epoch is a subdivision of period. So repeat after me. Eon is the largest and broadest category of the geological time scale, and era is a subdivision of eon, and periods is a subdivision of era, and epoch is a subdivision of periods. Next, we have years. Years are the geological time based on relative and absolute dating. Some geological timescale will not have the events, but most geological timescale will have the events. The events are major events related to a specific era, period, and epoch. Now, let's summarize what we have learned today. There are 4 major scientists who contributed to the origin of the geological time scale. And who are the scientists? Nicholas Stannus. And who are the scientists? Nicholas Stannus. And who are the scientists? Nicholas Stannus, James Hutton, William Smith, and Charles Lyell. The years of strata in the geological timescale are the years of strata in the geological timescale. The years and strata in the geological timescale are determined by the relative dating, which is non-numerical, and absolute dating, which is numerical. The geological timescale is divided into its compartment parts. the eon, the eras, the periods, the epochs. Remember, eon is the largest and broadest compartment. Then eras are a division of eon, and periods are a subdivision. Remember, the geological timescale is divided into its compartment parts. Eons, remember, is the largest and broadest compartment of the geological timescale. Eras is a subdivision of eon. Periods is a subdivision of eras, and epochs is a subdivision of periods. Learn it like that. If you learn it like that, you will be able to memorize it. We can do it one more time. Eon is the largest and broadest compartment of the geological timescale. Eras are a subdivision of eon. Periods are a subdivision of eras, and epochs are a subdivision of periods. I hope you had a good time learning about the geological timescale. As we progress in this unit, we will learn more about it, and we will be able to memorize each compartment.